Hi, welcome to Supercomputing 2015. I'm Jason Stowe. I'm the CEO of Cycle Computing.
And I'm Tim Carrolll. I'm the VP of Ecosystem and Sales, and another great day here in Austin.
Cycle helps users run large compute workloads across a mix of internal infrastructure and public clouds like AWS, Windows Azure, and Google Compute Platform.
Because of the industry that everybody's created, we've got the demand for compute and storage to solve really big problems is growing off the charts, and conventional infrastructure can't keep up. And so public cloud is a great way for people to be able to run workloads they weren't going to be able to run before.
Traditionally, with internal infrastructure, capacity has been a constraint. The capacity for data center space, for power, for cooling, for compute time. So users have had to size the science they're running to the infrastructure they had on hand. Cloud offers the opportunity to rethink that, and that's why people are interested.
There's nothing that's broken about what's going on today. That's a big misconception. Cloud's not fixing anything. All cloud is doing is cloud is handling the workloads that shouldn't be run on the infrastructure that's being run today, and are actually taking up valuable cycles off the infrastructure that's deployed when it could be run far more cost effectively and a lot more efficiently somewhere else. So nothing's broken. We're just making the good better.
Yep. It's another tool in the tool belt to help run the science. Yep. So HPC in the cloud is essentially the ability to ask the right question. It enables you to have zero QA times, to not think about capacity, and instead think about the problem you're trying to solve and build the infrastructure to answer that problem, not try to fit the question you're asking to the infrastructure you have.
We don't need to recreate what's already here. The notion that somehow you're going to do what we've been doing internally and do it externally is pointed in the wrong direction. What we're actually doing is we're filling in all of the gaps that exist today in the way that internal infrastructure is deployed and running it externally, and doing it in a way that makes it very, very easy for the largest to the smallest entry-level user to get access to it.
We really just want to increase access to compute power, and cloud is a phenomenal way to take workloads that might not fit in the traditional model and give users another tool in the tool belt to answer those questions. So in cloud HPC, there are still constraints around network types that are available. We have seen RDMA become available on Windows Azure as an example. From a practical standpoint, it's a lot about data movement, it's a lot about the workflow, it's a lot about making it easy from a technical standpoint to run workloads on both internal and external infrastructure, and those are the problems that we're solving.
Having spent 15 years in this industry, I think I've earned the right to poke fun at ourselves. But HPC people love to take and tackle the hardest problem first instead of the simplest one. So a lot of the technical barriers that people throw out in terms of running HPC in cloud are only technical barriers if you're trying to solve what's virtually an unsolvable problem. Instead, what we should focus on is taking the things that we can do right now, do them, and build our way to solving some of the more technical challenges.
Yeah, the best way to get started is to get started. In 5 years, we expect to see much of what we're seeing today. So if you look at customers like HGST or NASA, they have a mix of internal infrastructure and external infrastructure, but their queue wait times are zero. So as soon as they get the data to run a workload, they can run it. As soon as they have a question that needs to be answered, instances are spun up, the workloads run externally, or it's routed to an internal environment that's ready to run that job. So 5 years from now, we'd expect to see what's going on today, but pretty pervasively across the industry, and hopefully, I think, the 5-year goal should be getting rid of queue times altogether.
And in another view, 5 years from now, the higher end specialized machines are going to get more specialized and are going to provide even greater value to the constituents they serve, and at the same time, we're going to continue to run more and more workloads on public clouds and places where they can be run cost effectively. So in a sense, we're going to see all sectors of HPC continue to grow as a result of these new ways to do computing better.
One of the other interesting things that I think is changing is the workload type. So we're going to see a lot more machine learning, a lot more analytics, a lot of newer classes of workload that aren't just traditional MPI. And these are workloads that will fill large volumes of compute infrastructure, both internally and externally.
People ask us all the time, what's the best way for me to get started? And it's a pretty simple answer. The best way to get started is just get started. This is a technology that you don't need to bring in loaner hardware or anything else. You can get yourself an account, get your workload, and you can be running on a public cloud tomorrow.
Pick the workload that's a bottleneck, pick the one that doesn't belong in your internal infrastructure. If you've got a Maserati super fast network internally, run the batch job that's holding up queue times, run that externally. Pick the easy one. From everyone at Cycle Computing, thanks for joining us at the booth today, and hope you enjoy the rest of Supercomputing 2015.
We'll see you next year.